last bit of the analytic methods talks about the squeeze theorem. And the squeeze theorem is useful for a couple of different reasons. Basically what the squeeze theorem says is that if I have two functions f and g where x is near a, then both limits exist. We get that f of x, the limit of that, is going to be less than or equal to g of x, the limit of that. And that just basically means if I've got two functions and one is bounded by the other, then the limit of one is bounded by the limit of the other. Okay? We can extend that to having three functions. So if f is less than or equal to g, which is less than or h, then the limits fall in line same way. And if we can determine that the two outside limits have the same value, that forces or squeezes the third limit to be the same as well. Okay? And so an example of this would be our function limit as x goes to 0 of x to the fourth cosine of 2 over x. And I want to caution you on this one because your first thought should be, well, I have a product of two functions, so we can just use our limit law and combine the two. But the problem with that is, if I look at the limit of the first, it goes to 0, but the limit of the second function does not exist as x goes to 0. So you can't use that property. Both limits have to exist in order to use the product. And so here, to find the limit of the function, we can use our squeeze theorem. And basically what that entails is I've got to find two functions that I can find the limit of and figure out what they're doing as x approaches 0. Okay? And I need to bound my function by that. So here, in order to bound it, the first thing we notice is, if we recall, cosine of any value is always bounded between 1 and negative 1. And that's a nice property to remember. So it doesn't matter whether it's 2 over x or x squared or whatever. If it's inside of the cosine function, then it's always going to have a range between negative 1 and 1. Okay? So, if we let f of x equal negative x to the fourth, and h of x equal positive x to the fourth, we can see that the limit as x goes to 0 of f of x is going to be 0, and the limit as x goes to 0 of h of x is also going to be 0. Okay? And so I picked these functions because they relate a little bit to our cosine function, but more importantly, if we look at these functions, negative x to the fourth is always going to be less than or equal to x to the fourth cosine of x, or 2 over x, and this is always going to be less than or equal to x to the fourth. Okay? And that's because no matter what our x value is, cosine of 2 over x is at most 1 or negative 1. And so if I look at the functions, we can clearly see that negative x to the fourth is always less than or equal to x to the fourth. And if this is at most 1, going down to negative 1, this value is always smaller than x to the fourth. And if this is at least negative 1, then this value is always bigger than or equal to negative x to the fourth. Okay? So if we look at the limits of these, as x goes to 0, again, based on our squeeze theorem, it says that because this line is true, we get that the relationship between their limits is true. And now from what we've said here, if f of x is x to the negative, or negative x to the fourth, the limit of that is 0. And if we look at h of x being x to the fourth, the limit of that is 0. So we have a limit that is greater than or equal to 0 and less than or equal to 0, which means that our limit here has to be 0.